we're going to look at how pH can affect solubility. So let's look at calcium oxalate in equilibrium with calcium ion and oxalate ion. According to Le Chatelier's principle, as the oxalate ion is removed, if we reacted it with H+, then we would shift the equilibrium this way. And so more calcium oxalate would dissolve. So we would have a shift in the equilibrium, and the calcium oxalate would be more soluble. So what this means is if you put calcium oxalate in acid, the acid would react with the oxalate ion and would make a weak acid. So you would have an equilibrium with the oxalate ion and the hydrogen ion because this is a weak acid. So essentially you are removing oxalate, and then the equilibrium would change, and so the calcium oxalate would be more soluble in acid. So we have a list of various salts, and the question is asking if they would be more soluble in acid than water. So the water would be the normal KSP. But let's see what happens with barium sulfate. First, we have to write the equilibrium reaction for barium sulfate. Barium sulfate would break up into barium ions and sulfate ions. If we had an acid, then we would have H+. The H+ would combine with the sulfate to give monohydrogen sulfate, which is a weak acid. So we would have an equilibrium. So we are removing the sulfate, and so we would shift our equilibrium this way. So the acid would shift the equilibrium towards products, and that means that the barium sulfate is more soluble in acid. Let's look at lead chloride. We take the lead chloride, we break it up into lead ions and chloride ions. The chloride combines with the hydrogen ion, but we know that hydrochloric acid is a strong acid, so it's just going to break back up into the chloride. We have no shift in equilibrium. Therefore, the lead chloride is not more soluble in acid. Let's look at the iron 3 hydroxide. So iron 3 hydroxide is in equilibrium with iron plus 3 and hydroxide. we have H+. It will combine with the hydroxide to give us water. Water is a stable molecule. So we only are going this way, which means we are, according to removing a product, we are going to shift the equilibrium this way. We are removing the hydroxide by forming a stable molecule, which will then shift the equilibrium. So the iron 3 hydroxide is more soluble in acid. So if we make a stable molecule, then we have no equilibrium between hydroxide and water. So let's look at the calcium carbonate. So calcium carbonate is in equilibrium with calcium ion and carbonate ion. We have acid that makes carbonic acid. You should remember from your prior chemistry classes that carbonic acid spontaneously decomposes to give you water and carbon dioxide. So you are removing the carbonate, which means you are shifting the equilibrium towards products, which means the calcium carbonate is more soluble in acid. So we have 3 different examples that were more soluble in acid. So if we have an equilibrium, such as this example with a weak acid, we will remove product. If we remove product, we are shifting the equilibrium towards products. If we shift the equilibrium towards products with a KSP situation, that makes the salt more soluble. So because we'd added the acid and we pulled away products, our barium sulfate was more soluble. The second situation was one in which we had made a strong acid. So you need to know your strong acids, because if you make a strong acid, it will just go back and break up to its components anyway. So you still have the same equilibrium. There's no shift in the equilibrium. And in that case, that salt is not more soluble in acid. The other situation that we had was that we made a stable product. So in this situation, the hydroxide would combine with the hydrogen ion to make a stable molecule. So when you make a stable molecule, you do not have equilibrium. You're pulling away product. When you pull away product, you shift towards the products. And in this situation with a salt, if you're shifting towards products, that salt is more soluble. So this iron 3 hydroxide is more soluble in acid. And then the last example we had was that we removed the product because in turn it created a product that itself would undergo a reaction, and in that reaction we had made a gas, and when the gas moves or leaves, now all your reactions are going this way. So you're definitely removing the carbonate because the carbonate makes the carbonic acid. The carbonic acid spontaneously decomposes. Again, you're shifting towards products, which means that your salt is more soluble. So it's more soluble in acid. So those are 3 general examples.